This is how you create a stitch image using Agisoft Photoscan. First, you have to add the folder of the images that you have taken using UAV or other software. So you can do that by clicking Workflow when you open your Agisoft Photoscan. Go to Workflow and then Add Folder. So once you have the right folder, you can select that folder and you now create the images from using the create camera from each file. So this is usually done when you have, say, a UAV flying over a given area, and then you capture the images of the area in, let's say, a specific regular time interval. So select this one and then click OK. So once you have that, you will get the points. Okay, these are the coordinates of the images taken by the UAV. Now, if you're using, for example, GS Pro, you might have a very regular pattern, but this is taken using manual mode of the UAV, so there's no regular pattern in taking the images. Now, the image will be shown below. Okay, now make sure that when you put the images in the folder, they are of the same height. Otherwise, we will have a problem stitching them together using the software. Okay, so it's better that you create a new folder and then put all the images that you want in that particular folder. Now, one rule of thumb is that there should be an overlap between your images. So maybe around 40%, 50 or 60% overlap, so that it will be easier for the software to stitch them together. Okay, so once you have loaded this, you can now go to Workflow and then you can select Align Photos. So what will happen is the Agisoft Photoscan will look into each of the photos, find the coordinates of the photos using the meta information, which are the GPS coordinates, the height, and so on. But it will also look into the overlap of the images, and then these images will be aligned. So select the Align Photos. There are different ways or accuracy in aligning photos. Okay, so if you want a very good alignment, you can select high, but this will take a lot of time in your computer. So for now, we will be using medium. Okay, so since we are not doing a pair selection, we just use disabled. But if you have other means of controlling the position, let's say using a ground control, then you can do so. So for now, since we did not put in any GCP or coordinates, points, then we just disable this one. There are also advanced features. Okay, so you can adjust the point limit in which you would the software will look into the images. So leave it as is. Okay, medium and then disabled, and click OK. So this will run for several minutes depending on the speed of your computer. Now we're about 99% for the alignment, and then Agisoft will now match the different points in the images. As you can see, we are still in around here 40% in the process. It takes time for Agisoft to match the points. So right now we are just 2% of the images. If you use smaller images or maybe less than 100, then this will be faster. Okay, so the alignment has been done and the structure has been estimated. So I think we have to save the file so that if something goes wrong, we can go back to the file that we have. So to do that, just click File and then Save. Now select the directory where the file will be saved. This is not the image, but the file containing the software steps that we are doing. And of course, the configuration of the program. So we will save this as UPLB. Okay. So once this is saved, we can now look into our image, but this is just the point cloud. Now we have to create some sort of ortho mosaic out of this. Now this is the workflow. After aligning the image or the photos, we now do or build the dense cloud by clicking Build Dense Cloud. Now we can select again high, medium, or low quality. Let's select the medium quality so that it will be faster. So click OK, and then this will be processed. This again takes time, and in this case it will be about 40 minutes to be able to reconstruct the image. I'm now using Ryzen 7. Okay, so with 8 gigabytes of memory, and so as you can see, it's still very slow in processing the images. Okay, after that process of building the dense cloud, we can now build the mesh. So we can select an arbitrary type. We can select high field. So let's say just arbitrary. Now the source data is the one that we did, which is the dense cloud. And you can change the polygon count if you want to high or to medium. So let's try creating the high one, although this will take a longer time. Okay. And then Agisoft will generate the mesh. The mesh really is the surface that connects various points in the image. This will be done so that we can create a 3D render of the image. Okay, so we have finished creating the 3D render, and we can now view our image. Now, as you can see, this blue here is really the position of the camera. As you can see, the black lines are the direction of the camera. If they are all vertical, then that means the drone took the image straight down. But if there are slants, for example, in this area, then the image taken are at an angle. So if we want to view the image, we can now change the view. We can hide the camera. There is a button here which can toggle the camera view. So if we click this one, we will remove that camera positions. With Agisoft, you can also view the image in the different orientation. By clicking and dragging the mouse, you can view or rotate the image. And as you can see, as you zoom in, you should be able to see somewhat a 3D render of the image. But in reality, this is not really a 3D image because the camera of the drone is only looking downwards. And so if you look at it, for example, some areas like trees, they are not complete because the camera can only see the top of the trees, for example. The Agisoft Photoscan is best used for images that you want to render 3D. It takes time for the software to generate a stitch image. So if your purpose of using this one is to just stitch the image, it's better to use other applications like the Microsoft Eyes, okay, or the image composite editor. This program, the Eyes, can stitch your image, but it will not produce what is known as a 3D render. Okay, we have saved our file in this folder and I opened this using Photoshop. So the Photoshop program can be seen here. Okay. And as you can see, this is the image that we have. We can zoom this. Okay, we can like this. And then we can select positions, for example, or we can move the image. So as you can see, this is the high resolution image using the camera that we have. Now this image is really taken during the time when the bridge at UPLB is being constructed. So right now, this is no longer visible and you now have some sort of a road here. Okay, so we can change, okay, and then we can fit to the screen. So this is where the road started, okay, from the Erie in PD Drive, and now this is modified. Oh, you have the bridge here. Okay, so you can zoom this, and then we can watch or determine which of the image you want to view. Okay. Now notice that there are some parts like this one which are not rendered. That is because that's beyond the scope of the camera. So you can represent your image like this, or you can crop the image in the square or the rectangular form which you want. Now this is a pretty good image compared to the other software, which is the Microsoft Eyes, but it takes time to generate this. Okay, so that's how we were able to generate the stitch image from Agisoft and save it using, say, a TIFF file, and then open using a software like Photoshop. After creating the mesh, we can now go to the next procedure in the workflow, which is building the texture. So click building texture, and then you now have different modes like a generic, orthophoto, adaptive, spherical, and single camera. We will select the orthophoto. Now for the blending mode, we just use the mosaic, which is the default. For the texture size, we can change the texture size per count, or we can just leave it as 4096 for the image. If you want a higher resolution, then you can change the texture size per count, but when you do that, the file will be very large. You can also use the advanced button and you can enable the color correction. So for now, just leave it as orthophoto, mosaic, and then texture of 4096. Click OK. So this will be processed and it will take time to do the processing. Once finished, the image is now textured, and as you can see, it is much better than the previous image. So with this one, you can now export the image, or you can move around to view the different parts of the image. So for now, let us just save the image as is, okay, and export it using orthophoto, and then we use export JPEG TIFF PNG. As before, we can make use of WGS84, okay, and then we can select, in this case, write KML file. So if we select write KML file, we will generate this file, and if we export this one, we can use this in our Google Map. So click export, and then this will be exported using TIFF. So we can make use of the same, our UPLB orchard, but this one with texture. And we'll try to look into the two later and see the difference between just using the mesh and the one with texture. Save this one, and this will be processed. Okay, so we're able to save the image with texture. Now, if we look at it now, if we view our image, you would see that it's a lot better because of the texture compared to the other one. So this is how we use Agisoft Photoscan to generate our 3D image of the photograph taken by our drone. And the process is like this. In summary, we first add folder containing all the images that we have taken using the UAV. And again, the images should be taken from the same height of the UAV so that the images will be regular. And there should be an overlap of the image of around 40, 50, 60, or 70, or even 80% to have or to get the best image. After aligning the photos, we now do or build the dense cloud. After building the dense cloud, we build the mesh, and finally we build the texture. Once we have the textured image, we can now save it as a KMZ file, KML file, TIFF, GIF, or JPEG image which can be viewed using other software. After we save our image as TIFF, we can now view it using, for example, Adobe Photoshop. So I'll open Adobe Photoshop and let's see what will be the new image. Let's open the new image that we have. And the image is now the one with texture. And we will compare it with the one without texture. This is the one with the texture. I'll exit this one. And if you look at it, we'll zoom it 100. As you can see, it's a lot better with texture compared to the other image. I will load the other one and do comparison. This is taken without the texture, and the other one is the one with texture. Okay. After creating the KMC file, we can now import it into Google Earth. For Google Map, we have to convert our KMC file into a KAML file. So for now, we'll just use the KMC file that we have created, and this is how you would want to do it. Now open Google Earth application and then install. If you don't have it, then install the Google Earth in your computer using this link. And then if you open the Google Earth application, you can just drag and drop the file into the Google Earth application. So let's see if we can do that. I will open Google Earth. So this is the KMC file. This one. And we're going to drag and drop the KMC file into Google. Okay, and then we zoom. So as you can see, we now have our image, the one that we took using the drone and processed using Agisoft Photoscan and added it into our map in Google Earth. Okay, so as you can see, this is the layer. We can remove the road so we can view it easily. Okay, and if we look at that, we can view it. Okay, now if you notice this one is not really aligned, so you have to do a little tweaking to change the coordinate of the image to fit into the Google Earth map. Of course, that can be done if you can set your image. If you have different points the GCP in your image, and then you can align your image before or prior to creating the KMC file. So you can remove it to view, and you see there are changes in the layout. With Google Earth, you can modify your view or perspective, and that can be done by clicking on the icon on the top right to look around. So if you click the up arrow, okay, you can view, for example, the whole area, and you can see that the image that we captured is still overlaid but at a different view. Okay, so that's how you use Agisoft to create your image, stitch them together, and then create what is known as a KMC file, and then export it to Google Earth.